So hello children, we move on to our part 4 video lesson on factorization, which I told you we also called remainder and factor theorem. So I'm going to solve a couple of questions, 2-3 questions maybe. So first I'm going to solve the very latest 2020 question. So one on remainder theorem, I hope I have solved it. So factor theorem was left, which I did many sum in part 1 of my video, but 2020 somehow got left out. So here we start. So all the idea I have given you in my part 1 and part 3 basically. Part 1 about factor theorem, which we are going to use here, and part 3 was specially dedicated to remainder theorem. But today I'd like to do 2 factor theorem and at least 1 question on remainder theorem. So here we start. Use factor theorem where none of the factor is given, children. So our first idea is to what we call start with a trial method. So trial method F1 we take. I have taught you in my part 1 video. Simply add the, because 1 cube, 1 square, everything x is 1. So just you add them. So you will see when you add, they will not be equal to 0. You can see here 6 plus 17, 23 plus 4, 27 minus 12 is 15, which is not equal to 0. Okay, 23, 27 minus this. Similarly, if you try with 1, so what I told you, odd and even place you change the sign, because minus 1 cube is minus 1 and minus 1 in place of x will make it minus. So odd places sign will change and even places sign remains. So minus plus minus, and this was already minus. So what do we get, children? Minus 10 minus 22 plus 17. So we get minus 5. Okay, minus 10 minus 22 plus 17, which is not equal to 0. Next we try F2. F2 here, as I taught you earlier, this becomes 8. Okay, this becomes 4, because getting the factor carries 1 mark. So this does not carry any mark. Getting, like here in this case, I think this will give you the remainder 0. So this, we will see x plus 2 will be a factor. Okay, so here 4 plus 14 into 2 minus 12. This will also not give you equal to 0. So finally, I think this one we try. 6 into minus 2 cube plus 17 into minus 2 square plus 4 into minus 2 minus 12. So what do we get, children? Minus 8, 6 are 48, 17 4 are 68, minus 8 minus 12. I think this will give you 68 minus 68, which is 0. So see a 68, 56 and 12, 0. So since, okay, 2 dot up, 1 dot down, since f minus 2 is equal to 0, therefore x plus 2 is a factor by factor theorem. Okay, so what we do, we get the first factor. Now we divide the given expression is a factor of fx, you can say here, of fx. So we divide this by x plus 2. So let us see, we get 6x square. I'm writing up. Okay, 6x square into x is 6x cube plus 6 2s are 12x square. We subtract, we get 5x square plus 4x. So we do 5x square plus 10x. We subtract, we get minus 6x minus 12. So we do minus 6. So the more you practice, the faster you will be able to do. So here we get factor as remainder as 0, means this is a factor which we have got by factor theorem. Last step. So kindly pause the video and copy in the last. So here, just to tell you, it carries 1 mark here, children. If you come here generally, you get 1 mark. When you get this, you get another mark. This was a 3-mark question in the year 2020. So last mark we will get for getting the final answer. So I need more space. So please copy. Then we will see the last step of this question. So we move on to the final step. So see here, we have got one factor. With the help of that, we have got a quadratic. Now this you can work out here, this breaking, or we do here only. So one thing I'll tell you here, if you want to do, you don't show this in the rough work, this should be in the, so I'm just explaining factorization over here. So product of two number should be minus 36, this into this, okay, and sum of the number is 5. So what you do, the best way is that take the factor of 36, okay. So here if you see, we need product of two number 36 and the sum is 5. So you see, sum is 5, we will get 9 and 4. 9 and 4 gives you 5. How will it give? Yeah, I want the product to be minus but sum to be plus. So bigger is plus and the smaller is minus. So see this two number, 9 into minus 4 is minus 36, plus 9 minus 4 is plus 5. So it becomes easier. So you can do separately or here. But what is most important thing is, which I'll tell you, which gives you, so fx is this. So here I'm just showing you, I write the full cubic expression, okay. So fx is this, you can write this. So this is product of 3 factor, this is a cubic equation. So here see the use of bracket, 6x square plus 9x minus 4x. So if you see children, this is the only big middle term breaking called trinomial. So now where you will get the last mark, I'll tell you. So take out 3x common, 2x plus 3, take out 2, okay, 2x plus 3. So see here, 6x square plus 9x minus 4x minus plus 2 3s are 6. So our final step is 2x plus 3 you take out, 3x minus 2 is left. So very important thing children, before I go to other question, this cubic equation has one factor and this is a quadratic. Quadratic you break into 2 factor. Okay, this is quadratic expression because when you make it equal to 0, then it is equation. So this final mark you will get not for writing this 2. Once more I am stressing, all 3 should be there, then you will get your final mark in the exam. Okay, so some children write this only. See, this is a cubic equation. So I've rubbed it there. You can see the dividend is when remainder is 0 is divisor into the quotient. So this is your divisor and this is quotient, and we do the middle term breaking of quotient and we get the 3 factor. So children, this is your answer to year 2020. Then we move on to the next question. So kindly pause the video and copy. So here we go to the ICSE question on remainder theorem, 7 part 2 of ML Agrawal's book. This is not ICSE 2020, that was the previous one. This is 2015. So next, just one remainder theorem which I did full video lesson, that is my part 3, you can see. So just I am showing you one more question on remainder theorem. So see how we do and what the question says. There are 2 cubic expressions given. I call it fx gx. This is how the way we do. When divided by x plus 3, they leave the same remainder. So the polynomial leaves the same remainder when divided by x plus 3. That means f minus 3 is equal to, I told you we change the sign. So you can write by remainder theorem. Okay. So here we start f minus 3. So see here, this gx, okay, I'm writing little up so that I need that full space. So gx, I'm writing it over here because when I do substitution, children, I need it. So see here, how we do is we substitute. So children, we are going to substitute in this equation, first equation, f3. So wherever I have, so I'm writing the full equation here. See here, f3 ax cube. So a in place of x, we will write minus 3. Okay, so plus 3x square. So wherever x is there, we write minus 9. This is equal to, in gx you put minus 3. So g minus 3 we have to find. So wherever x is there, we write minus 3. Okay, so you will see one thing, children, is that we have a both the sides. So this becomes minus 27. So one equal to is there, don't put equal to. You put implies sign, or in our time we used to write or. So nowadays we use implies sign. Minus 27, 9. This is 27 minus 9. And this you see minus 54 minus 12 plus a. So both the a I do on the one side, and this side I take all the number. So minus 27 minus 9 is minus 36, becomes 36 here. Okay, so and what we are left with here, minus 66. Okay, let us check. So see children, this was 27. So this will be 27 minus 9. This will be 18. Okay, I was thinking 27. So this already I have taken. So this is 18. So here this will become minus 18 when it goes to that side. Anyway, let it be a only. So this is next step I'll do. A is here, and this side we get minus 66. So minus 27 minus a, so this side we will get minus 28. This is minus 66 plus 18 will become minus 18. So we get minus 84. So a is minus 84 by minus 28. So we get 3. So check once more whether we have substituted, done the transposing and all properly. So you see we get minus 28a is equal to minus 84, and when you divide you get 3. So kindly pause the video and copy. We move on to the next question. So now I go to my last question of this session, where I'm going to do question 18 from M.L. Agrawal's book, exercise 6, and this came in the year 2008. So if you see children, in my 4 videos, I think I've solved more than 10 to around 10 to 15 ICSE questions. So please do them, and then you do other ICSE questions as I have told you. Now, in this particular question, x minus 2 is a factor. So first here see, we have to get p with the help of that. We know this is a factor. So when x minus 2 is a factor, by corollary 1 to factor theorem, f2 will be 0. Okay, so generally one shortcut method you will see some author and some book they use, which is I think mathematically not very logical. So something like this they do and they write, but I think this is has a correct mathematical logic. Now, so what we will do, wherever x is there, we will put 2 and we will put it equal to 0. So see what happens here. In place of x, I will put 2. So 2 cube minus 2 square minus c. Remember, we have to solve for p, children. First we have to get p, then fully we will factorize it. Okay, so this is equal to 0. So we get 8 2s are 16 minus 4 minus 2p minus 2 is 0. I see 2p, if you see here, 16 minus 6 is 10. So first mark you will get for getting p is 10 by 2, which is 5. So this gives you the first mark. And now we will go. So this may be 3-mark question. So 1 mark for p. Then next step what we will do, children, once we get a factor. Now this equation fx, if you see, has become, when I get p as 5, so this is my original cubic equation now when I know p. So next step what will I do? I will divide one factor I know, x, this fx by x minus 2. So x minus 2 is a factor, and let us see what do we get, children. Okay, so I'm writing here 2x square is the first factor. So you get 2x square. So you subtract. Okay, so we get x square minus 5x. Next you do with x. Okay, so we get x square minus 2x. Okay. So children, if you see nicely, this 2x square into x is 2x cube, but 2x square minus 2 is minus 4x square. So this will give me 3x square. So 3x square means this I have to multiply with 3x. You multiply x, then you get 3x square. And plus 3 minus 2 is minus, and 3 2s are 6. So now when you subtract, children, this will cancel, we get x minus 2. So you do by one time, you get x minus 2. So our quotient is this. So kindly pause the video and copy, then we move on to the final step. Now we move on to the final step, children. So you see, when remainder is 0, so dividend is divisor into quotient. So this is this into this. So finally we need to break this. So you know cubic equation is this into quadratic equation. So here if you see 3x, so I think this is how you will do factorization. Not a very tough factorization. See the use of bracket. Take 2x common. You get this. Take 1 common. Okay. So finally our complete factorization is, children, this. So once more I'm telling you this. So last mark is very important, children. The last mark you get here. This is the second mark. Okay. So this is the last 1 mark. This is the second mark. And first mark was to get p as equal to 5, children. So I've done. So 3-mark question, I'm telling you the mark distribution generally, which is followed in any standard examination. So this is this into this, because remainder is 0. You can do separately also breaking, but doing in the last step is important, because this is this. So don't miss x minus 2. If you miss this, you won't get this mark. If you write this 2, then you factorize, see, you get back the same thing. So there are always, remember, 3 factors to a cubic equation. So kindly pause the video and copy. So with this I come to the end of my fourth session on remainder and factor theorem. So if you want to practice more, what you do exercise 6 everything now, all ICSE and non-ICSE question, do the full thing. Okay, and if you have already done, if you have not done, you do it, and after doing this, or if you have already done, go to the chapter test of ML Agrawal's book. There are many interesting questions. So once you finish this, then I think we will be ready for some other chapter from our ICSE syllabus. So thank you children for watching. Please do practice.